Okay, so we are looking at tutorial sheet 5, tutorial sheet 14, starting from question 5. In question 5 reads, differentiate each of the following functions. And the first one is the function f of x is equal to log e 5x plus 1. Now, on the properties of logarithms, we said we have two standard bases, base 10, which can just be written as log, and base e, which can be written as a ln. So we'll write as ln and then do that. Okay. From there, we now differentiate. So differentiate a ln function. If I'm given f of u and u is a variable, the derivative of f with respect to u will be 1 over u. Okay. If I'm given f of x is equal to ln u, where u is a function of x, the derivative of f with respect to x is going to be the derivative of u divided by u itself. Okay, so in our case here, we'll let u to be 5x plus 1. U is a function of x, and so the derivative of u in this case is 5. So the derivative of our f is going to be u prime over u, which will be 5 over 5x plus 1. You do that. And then b, we have f of x is equal to ln x squared sine x. So nothing has changed. Okay, it's now a direct ln where we just let our u to be x squared sine x. And then now we use product rule to differentiate x squared sine x, where we are saying the derivative of u is going to be the derivative of x squared, which is 2x, we multiply by sine x, plus x squared, the derivative of sine x, which is cos x. Now we go back and find the derivative of f with respect to x, so it will be u prime, which is 2x sine x plus x squared cos x over the whole u, x squared sine x. Okay. Another way of dealing with such functions of ln is by saying, because I know the properties of logarithms, if the two functions are multiplying and they are the same base, I can split them by addition. So I can write this as ln x squared plus ln sine x. Okay, you can then differentiate now. Okay, the derivative of x squared here will be 2x over x squared plus, okay, the derivative of sine x is cos x over sine x. This is also the same thing. Okay, because if you want to get the common denominator here, you can get the common denominator. You have x squared sine x as a common denominator, and x squared in here, you get 2x sine x plus sine x in here, you get x squared, and then cos x. It gets back to the same thing. So you can write that in different ways. Someone can present this as 2 over x plus cot x. It's the same answer. It's the same answer. So nothing has really changed there. Okay, so we go to the next question. We look at C. C is f of t is equal to log 3 x squared plus ex. Wow, now we have a log 3. Do we have a standard way of going about different logs if the log is not e? I mean, what do we do? Now remember, we are able to change the base from a to b by doing that. Okay, this is the standard way of changing the base. So why can't we change the base here if we don't know anything about log 3? So we change the base to ln. Ln, when I say ln, I mean log e. So to ln x squared plus ex and divide by ln 3. Wow, we can now differentiate. Yes, because this outside here is just, this is just a constant. Okay, so inside here we have ln x squared plus ex. So what is the derivative? So because of the x inside here, this was supposed to be x. It cannot be t. Otherwise, everything there will be constant. So we have x is equal to 1 over ln 3. You differentiate ln x squared plus ex. It will be 2x plus ex. And then divide by the whole function. Okay. In other words, what you are saying is that suppose I'll be given a function of this form. Okay. Log a u, where u is a function of x and a is a different base from e. So the standard one will be writing this as ln of u over ln a, so that when you differentiate, you'll be getting u prime over u ln a. So this will be a standard derivative, u prime over u ln a. So let's see if we can have another question of the same kind. Wow, we don't have. The one that we have is a bit complicated on E there. Okay, let me give you something nice. Suppose there was, so that we can just see how this comes into play directly. So they ask you to differentiate log 4 x3 plus 4x. Okay, so what do? You say, okay, let u be x3 plus 4x. What will be u prime? It will be 3x squared plus 4. Okay, so it means that the derivative of this function is going to be, u prime, which is 3x squared plus 4 over u, which is x3 plus 4x multiplied by ln a, and a is 4. That's how easy you get the derivative. Very easy, no complications. Okay, you got the next question, that is D. The D, we are dealing with f of x is equal to e to the power x ln x. Now normally when you have e raised to the power to the exponential, e raised to the ln, those two must break down. But in this case, it becomes a bit complicated because if you try to break them down, you're going to have x to the power x. Then how do you differentiate it? You need the logarithm back. So you don't just go there. You just differentiate it in the normal way. We've been differentiating the functions of exponential when they have powers, where we differentiate the power. In this case, we let the power to be u, which is x, then x, and then use product rule. You differentiate x, you get 1, you multiply by ln x, plus you keep x and differentiate ln x, which is just 1 over x. Remember, the derivative of x is 1 over x itself. This is just the ln x plus 1. So you come here now and say 1 plus ln x multiplied by the whole function. And that's how we get the derivative of such function. That one was the easiest. Okay, what about e? E, we have f of x is equal to log 2 and then log 5 the square root of x squared plus 1 close. Remember what we generalized here? Okay, so this means that if we let our u to be log 5 the square root of x squared plus 1, the derivative of f prime of x is going to be, because now the function has changed, remember? What we have now as a function is, it has now become log 2 u. So its derivative is going to be u prime over u ln 2. Okay? But look at u. In u again, we can let v to be the square root of x squared plus 1, so that we can write it as x squared plus 1 to the power half, and then differentiate v so that we get what? So that we get half x squared plus 1 negative half 2x, and this becomes x squared plus 1 to the power negative half, which you can write as x over root of x squared plus 1. That's the derivative of v. Okay, now that derivative of v, when we come to differentiate u, following that same generalized formula, this is going to be v prime over v ln 5. That is u prime. Okay, so when we come back to this, where there is u prime, we are taking v prime over v ln 5 and then divide by u ln 2. Now before we make any substitution here, shall we write this? Okay, this is the same as this guy has over 1. So we have v prime over these two multiply, because this becomes v ln 5 multiplied by 1 over u ln 2. So this can be written as v prime over ln 2 ln 5, and then what? And then uv. We can multiply them like that, so that our f prime of x is, what is v prime? V prime is x over the square root of x squared plus 1. Everything we divide by ln 2, also ln 5. Remember, these are just constants. And then u. So what is u? Which one do we start with, u or v? Okay, let's start with v. So v, the square root of x squared plus 1. And then u, that is log 5, the square root of x squared plus 1. So this becomes our solution, which if you want, again, this is just like this guy down here has over 1. So again, you can reciprocate and get x over, now when this and this part multiplies, because now we're having the product of this here and this line. So it means that these two here will have to multiply. So when they multiply, remember, we'll have ln 2 first and ln 5. When those two multiplies, only x squared plus 1 will remain, and then the log 5 square root of x squared plus 1 remains there. So we get something like this as our derivative. A bit long, but if you take your time, you'll be able to understand this. So just go through it again, then close this, write it somewhere and see if you've grasped the concept. Okay, so we move next. We go to question 6. So question 6, use the rules of logarithms to simplify the expression and then find the derivative. A, you are given f of x is equal to ln the numerator x plus 1 to the power 16 multiplied by 2x squared plus x to the power 8, everything divided by the root of x squared plus 4. Okay, so the root comes this way. Okay, now to apply the rules of logarithms means where you find a multiplication, you add. So you're going to have x plus 1 to the power 16 plus ln 2x squared plus x to the power 8 minus ln, because that's division there, x squared plus 4. You can simplify further. You bring 16 down and have x plus 1. You bring 8 down and have 2x squared plus x minus, you bring the half down. Remember that root is just the same as half, so that you have x squared plus 4. You have now simplified. You can differentiate. So to differentiate, that will be 16, the numerator there, because the derivative of x plus 1 is 1. So we'll just take the x plus 1 down, plus 8. The derivative of 2x squared plus x is going to be 4x plus 1, and then divide by 2x squared plus x, minus, this is half. The derivative of x squared plus 4 is 2x, and then divide by x squared plus 4. If you have the energy to simplify, please simplify, but this is the solution. We go to B. Again, simplify. So you have f of x is equal to ln e 2x plus 6 to the power 7, the square root of x plus 4, everything divided by e negative x plus ex to the power 5. Wow, so to simplify first, that's the first thing. So you say this is the same as ln ex plus 6 to the power 7 plus ln x plus 4. I'll write it to the power half because that's a square root, minus ln e negative x plus ex to the power 5. Then what next? You now drop the power. So you have 7 ln ex plus 6 plus half ln x plus 4 minus 5 ln e negative x plus ex. Then you can now differentiate because it has become very easy to differentiate. So you keep the 7. What's the derivative of ex plus 6? It will be ex, and then divided by the whole thing inside ln plus half. What's the derivative of x plus 4? The derivative of x is 1, for 4 is 0, over x plus 4, minus 5. What's the derivative of e negative x? Plus ex. The derivative there is negative e negative x plus ex over e negative x plus ex. So this becomes the derivative. If you wanted to simplify, you can simplify. Further, that is, if it changes anything. So that's how we differentiate. Okay, so we can go to question 7. Question 7. For each of the given functions, find the second derivative, third derivative, and the fourth derivative. Now let's start with 1. Y is equal to 2x4 minus 3x squared. Before you can get the 2y dx squared, you need to get dy dx, which is going to be 8x3 minus 6x. Now you can start getting what you've been asked to get. To get this, it means differentiating the first derivative. So differentiate the first derivative with respect to x. So it will be 24x squared minus 6. To get the third derivative means differentiate the second derivative. So it will be 48. It will be 48x. To get the fourth derivative means differentiate the third derivative. So it will be 48. If you want, you can get the fifth derivative, meaning differentiating the fourth derivative. So that was A. What about B? B is sine x plus cos y is equal to 7. Okay, so we differentiate first. Now this one is implicit, so it may not go as far as 4. Okay, so this one is implicit, so we first differentiate sine x, we get cos x, minus, we differentiate cos, it is negative sine y, but because that's where it is y, we put dy dx is equal to 0. And then to solve for dy dx, we take the cos the other side. When you divide by negative, it will remain positive. Now to get the second derivative, what do? Remember, there's sine y down here. Okay, this is sine y. So to get the second derivative, again, that is implicit. Remember with respect to y. So you first differentiate dy dx. So it's going to be d2y dx squared is equal to, so I differentiate on the left. On the right also we differentiate the derivative of cos x, that is negative sine x. That's quotient through there, multiplied by sine y. Okay, minus the derivative of sine. So we have cos x. The derivative of sine is cos y. But because that is y, we have dy dx over sine squared y. So it's not complete. So we have negative sine x, sine y minus cos x, cos y. We multiply by dy dx. So dy dx is cos x over sine y. This whole thing we divide by sine squared y. So you keep doing the same as you do other derivatives. So they are long, so I won't spend much time there. But you can see the same pattern. So when you want to find the third derivative, you differentiate the left, differentiate the right-hand side, and substitute where there is dy dx. Here, you're going to have the second derivative also when you differentiate. You don't even do that because you have substituted. So you keep substituting the first derivative. Okay. So we go to question 8. Question 8. Find the indicated value. So we are given f of x is equal to root of 4 minus x. And you must find f prime prime of negative 5. Meaning, you should find first the first derivative. Now, the root is the same as half. So in differentiating, we drop it down. And then we have that, subtract a 1, multiplied by the derivative of the inside, which is just -1. So this is -1/2, 4 minus x to the power -half. Okay, then when you differentiate for the second time, you drop the half, so you're going to have 1/4, positive now because it's coming as negative. Remember, it's -half, and then 4 minus x. You subtract a 1, now you're getting -3/2 multiplied by -1, the derivative of the inside. So this becomes -1/4, 4 minus x to the power -3/2. Then substitute where there is x now in this function, substitute -5. So you're getting negative that, 4 minus -5 to the power -3/2. That is -1/4, 4 plus 5, -3/2. That is -1/4. That is 9. So you're saying 9. So write it in the right order. So you're saying the square root of 9 to the power -3. So I've separated -3/2 there in those pieces, half, and then multiplied by -3. So that we get, because we know the square root of 9 is what? Is 3. But now we're going to have 1/3 to the power 3, so that the negative can lose power, and this becomes -1/4 by 27. So you should be able to finish up now. It has become an easy thing. So you can see you first need to find the first derivative for you to go the second derivative, and then substitute to get the value that you're asked to do. What about b? B is f of x is equal to x3 minus 2x to the power 3 at f prime prime 1. Okay, so you want to get the second derivative first. So you pass through the first derivative, you differentiate using chain rule. So you're dropping the power outside before you go and differentiate what is inside, which is 3x squared minus 2. Okay, now if you want, you can make these two functions. So you say this 3 here, you're multiplying by this one here. So it will be 9x squared minus 6. So that then you have x3 minus 2x squared. Then you differentiate this now. The second derivative becomes the derivative of this one, which is 18x multiplied by the whole second function there, plus you fix the first function and differentiate the second function, where you first drop the 2, and then you have x3 minus 2x multiplied by the inside, the derivative of the inside. So it will be 3x squared minus 2. Okay, and then you now substitute f prime prime, you take 1. So you have 18, whenever there's x, I'm taking 1 squared plus 9 minus 6, 2, 1 minus 2, 3 minus 2. So we're getting 18, -1 squared plus 9 minus 6, you get 3. And then 2, 1 minus 2, you get -1. 3 minus 2, you get 1. So you have 18, because -1 squared is 1, and then minus 6. This gives us 12. So we get such. So from there, okay, so I'll leave C for you to try. It's an easy question. F of t is equal to the square root of 2t plus 3. Just express it as 2t plus 3 to the power half. and differentiate the first derivative, again second, third, then substitute half where there will be t. Okay, so that we go to question 9. Question 9, you are given that if x3y is equal to 2, find the value of d2y over dx squared when x is 1. To make your work easy, you solve for you solve for y. So it will be 2 over x3, which you can write as 2x to the power negative 3. Then find dy dx. Dy dx will be negative 6x negative 4 because you're subtracting when differentiating. You subtract 1 when differentiating from the power. Then find the second derivative. That's how we denote it. So negative 6 multiplied by negative 4, you get 24x negative 5. Okay, remember, in the second derivative, we are asked to substitute. So at x is equal to 1. So we are looking for 24 when x is 1, negative 5. So what do you get? That is just 24. You should never bring the negative inside. The negative means 1 over 1 to the power 5. This is just the same as 24. Do not bring the negative from the power inside the function. It never goes inside. It just means that you are dividing 1 by that thing you have to the positive power. That's the meaning there. Okay, so you can go to question 10. Let f of x be equal to 2x minus x squared. Find the equation of the tangent and normal line to the graph of f at a point half, 3 over 4. Your first thing, whenever you're asked to find the normal line, to find the equation of the tangent line, those are lines. So they need the gradient. And how do you find the gradient? To find the gradient, you go to the function given and differentiate it. Okay? So we'll differentiate f. We'll get 2 minus 2x. Then substitute in that f, substitute the point given. In this case, we are substituting this. Okay? So this is first, you don't deal with two variables functions. In this case, we're just substituting. Where there's x, we take half. So it will be 2 minus 2 multiplied by half. This is giving us 2 minus 1, which is 1. This one we have found is the gradient of the tangent line. Okay? So we can, but then remember we have a relationship that says the gradient of the normal line. So let me say the gradient, let me use empty. Since we always denote the gradient as m, let me say the gradient of the tangent multiplied by the gradient of the normal give us negative 1. Now the gradient of the tangent, we have found 1. So what will be the gradient of the normal? It's just going to be, the gradient of the normal is going to be negative 1. Because you're dividing by 1. Remember, you're dividing by that 1. So it's going to be negative 1. So now we can start finding the equations. So tangent line, y is equal to, the gradient is 1. So we'll just say x plus c. How do you find c? You use the point given. y is 3 over 4, x is half, plus c. So you take this other side. So you have 3 over 4 minus half is equal to c, which is 4. 3 minus 2 is equal to c. That is 1 over 4 is equal to c, implying that the tangent line equation is y is equal to x plus 1 over 4. We got the normal line. The difference is just in the gradient. This will be y is equal to negative x plus c, because its gradient is negative 1. So again, the same point, 3 over 4 is equal to negative half plus c. Now it will be 3 over 4 plus half is equal to c. So 4 down, and then we have 3 plus 2 should be c, implying that 5 over 4 is equal to c. And so y is equal to negative x plus 5 over 4. So we have two equations, the equation of the tangent and the equation of the normal line. Now let me repeat something important. For you to find the equation of the normal, the equation of the tangent, lines, immediately you see the word line, you come to this equation. From there, you know you need to find the m, because it's easy to find the c. But how do I find the m? You differentiate your function with respect to x, with respect to the variable given, and then substitute in the derivative the value of that variable at the point that you're being asked, because we are asked for the line that passes through that point. So you pick a point on the line, substitute in there. What you get is the gradient of that line. Now, whenever you differentiate, you get the gradient of the tangent line. To get to the normal, you use the relationship of the normal and the tangent. The product of the gradients is equal to negative 1. So you can get the other gradient and then form the equations. Okay. At what point on the curve is the tangent line parallel to the x-axis? At what point? So we're now answering B. So let me write it in this form. So this was A. Yes, so we're now answering B. At what point on the curve is the tangent line parallel to the x-axis? It is when the gradient is equal to 0. That's a point when you do that. So what do we mean? We mean you equate the f prime of x to 0 and find x. That's a point. So you're saying 2 minus 2x is equal to 0, because this is our derivative. And so that is 2 is equal to 2x, divide by 2, divide by 2. So you have x is equal to 1. Now when x is 1, how do you get the other value for y? You go in the original function and substitute 1 and look for the y. So you have 2 minus 1, which is 1. So the point you're looking for is 1, 1. So at 1, 1, you're going to have the tangent line there will be parallel to the x-axis. That's what it means. Whenever the gradient is 0, then you have a parallel line. Okay, so we go to question 11. We go to question 11. Find the point at which the slope of the tangent line to the curve y is equal to 5 plus 3x minus x3 is 3. Find the point at which the slope of the tangent line, when we say the slope, we mean the gradient, when we say slope, whenever you see slope, just know that you have seen the word gradient. Okay, so at what point is the slope, or at what point is the gradient of the tangent line to the curve at 3? So you just get dy dx, which is 3 minus 3x squared. Now you have been told that the gradient there is 3. So you equate your derivative to 3. Okay, so take this other side, you remain with negative 3x squared is equal to 0. And then divide by negative 3. So x squared is equal to 0, implying that x is 0. And they're looking for the point. So y is equal to 5 plus 3, 0. Remember, when x is 0, you get 5. So the point is 0, 5. That's the meaning of that thing. Okay. Then find the equation of the tangent line to the curve. So we have another question here. That is question 12. Question 12 is just a follow-up on question 10. I could even leave it as a task for you to try. Find the equation of the tangent line to the curve 2y squared minus 3x squared is equal to 6 at a point 2, 3. Find the equation of the tangent line. What do you need? You need a gradient. How do you get the gradient? You differentiate. How do you differentiate here? Implicit differentiation is not that won't take us time. So you get 4y dy dx minus 6x is 0. So we have dy, I'm now solving for dy dx, is 6x over 4y. Then we substitute the point. So dy dx, we substitute 2, 3. So where there's x, we take 2. And where there's y, we take 3. So we have 12 over 12, which is 1. So the gradient here is 1. And so we're saying y is equal to mx plus c. But m is 1. So just have that. When you pick the point, it will be 3 is equal to 2 plus c. So c is 1. And so the equation is y is equal to x plus 1. That's the equation that you're looking for there. Okay, so from question 13, we're going to question 19. So these are the same concept. So I'll put them in the next video. So for now, we end here. Don't forget to share, and always ask your friends when you share to subscribe so that you can keep the channel running. Thank you.